Hey everyone! So I wanted to talk about area of triangles and how we can find area of triangles, and in particular when it comes to Heron's formula. So through the years in our mathematical journey, there's been in many classes we've been asked to find the area of triangle. And probably the most common formula to find the area of a triangle is area equals 1/2 base times height. So we have a triangle, and we know that a base and a height have to make a 90-degree angle. So usually in the triangle, in one way or another, they will give us the height, and we know that that's going to make a 90-degree angle with our base. And so we're looking at that relationship between that height and that base, and we can plug it into the formula and get our answer for the area. So today I want to talk about this Heron's formula. And Heron's formula is good when we know the three sides of a triangle. And for today's purposes, I'm not going to go through and actually prove Heron's formula and how he actually came up with his formula. But ultimately, you're taking this triangle, you're going to split it into a couple right triangles, you're going to use Pythagorean theorem, and then you can go and add those triangles together, and ultimately through some pretty hairy algebra, you can sit there and you can come up with the formula that we're going to talk about today. So for our purpose, I'm not going to go through and prove it. We're just going to look at the application of Heron's formula and actually apply it to some triangles. So with any triangle, we want to be able to label our sides and our angles. So we're just going to arbitrarily label this triangle A, B, and C. And we remember that when it comes to triangles, that there is that direct relationship between when it comes to our angles and our opposite sides. So if we're looking here as angle A, we know that on the opposite side of the triangle is going to be side A. If this is angle B, we know the opposite is going to be side B. And so this is going to be C. So Heron's formula to figure out the area of a triangle, the area equals the square root of s times s minus a times s minus b times s minus c. I'm still waiting for my new pen to show up, so my penmanship will hopefully get better. So when it comes to our formula, it looks a little daunting, it looks a little cumbersome right now, but once we kind of figure out what all of these letters actually represent, where the numbers are coming from, it falls out pretty easily when it comes to the actual mathematics and the algebra behind it. And if we look at our formula, we see that we have an A, a B, and a C, those lowercase a, b's, and c's. And we know that those are our three sides of the triangle. So the only thing that we're really wondering right now is what does this S all represent? So in Heron's formula, S is just half of the perimeter. So when it comes to the perimeter, we remember that perimeter is the distance all the way around something, or around this triangle in our example. So our perimeter is just going to be A plus B plus C, and then divided by 2 is what the S stands for in Heron's formula. So now that you guys know what the A, the B, the C, and the S all stands for, I know you're just dying to actually try a problem. So let's jump into one. So let's say they want us to find the area of this triangle. So I always ask myself though, because I really believe that that 1/2 base times height is probably one of the easiest area formulas that's out there. I look to sit there and see if I can actually apply that to this triangle. And in order to apply it to this triangle, I need to find the height of this triangle, because this is not a right triangle. You could test it by doing Pythagorean theorem of a squared plus b squared equals c squared, and we can tell that this isn't a right triangle. So, but ultimately if I wanted to find the height, and so let's say I wanted to find the height going this way, perfectly drawn straight line, right? And I make that 90-degree angle. The problem is I don't know what my angles are at this particular point. So I have to use the law of cosines to actually find out what one of these angles are. If you go back to the previous lesson, it gives that explanation on how to figure out that law of cosines. And then once I have an angle, I can then use more trig, sine, cosine, or tangent to then find the height. So it's perfectly doable on this problem, but it is going to be time consuming in order to do it. So sometimes we always say, work smarter, not harder. So Heron's formula is great for this example because we know three sides of the triangle. So if we apply our formula, area equals the square root of s times s minus a times s minus b times s minus c. Okay? So we can figure out what our a, b, and c are, but we need to figure out what our s is. And if we recall, s equaled our perimeter, a plus b plus c, all divided by 2. So for our formula, or our problem, we're going to say that a is 9, right, across from our angle. B is going to be 13 plus c, which is 12, divided by 2. And we can simplify that down and find out that s equals, what would that be, 34 over 2, which is going to give us 17, right? So now when it comes to our formula, we now know what s is. That's our 17. And we know our a, b, and c because those are our three sides of our triangle. So we have everything we need in order to plug into the formula, but then just simplify. So let's try it. So the area equals the square root of 17 times 17 minus 9 times 17 minus 13 times 17 minus 12. So the area is going to equal the square root of 17 times 17 minus 9 is 8. 17 minus 13 is 4. 17 minus 12 is 5. So I'm not a human calculator, so I'm going to plug this into my calculator real quick. And I get the square root of 2,720. And I'm going to figure out that's going to be approximately 52 point... Let me rewrite that. Approximately 52.2 feet squared. And technically when I take the square root, it's going to be a positive or a negative, but I know that because I'm talking about distance or area, technically in this model area, I know that it's only going to be the positive. And I just rounded it to the nearest tenth for simplicity. I hope you guys enjoyed the video and it was able to help somebody out. I hope you guys have a good day. I'll talk to you soon. Bye.